Seaworthiness management.
Thank you. Good evening, all. Thank you everyone for organizing this opportunity. Good to see you all. Hope you get department back on action after this COVID. You all back to classes. Can you hear me?
Yes, Sanu, we can hear you. Only thing is there is a bit of a noise in the background. Otherwise, it's all good.
Yeah, maybe someone not muted. I'm sitting in a quiet place. Just wondering what is happening. Akhil, can you hear me?
Yes, sir.
Can hear.
Sir, you're audible. I think we can continue.
Okay, no problem. All right. Welcome all. I thought I'd just take this opportunity to present what Australian Navy is doing to assure the seaworthiness of their ships. So seaworthiness means it's a technical integrity associated with the technical integrity of the ship. How that is managed, that's what it's all about. How the ship certification is maintained, how the Navy makes sure the ships are safe and it's good to be at sea and ready to be on mission, continue with their combined operations. This presentation is not purely, I've tried to customize and I've tried to reduce the standard definitions used in seaworthiness management system. The reason is it's very difficult to it will be boring for you to read out of some manuals. So what we do is even though the regulatory body says these are the things to be done, we can develop our own process in accordance with the regulators procedures. It is something similar to ISO management system. We call ISO 9000 or 9001 standards. You take the standards, bring to your company or bring to your organization, make it use that principles to incorporate into your business. This is something similar to that. So I'll just go through our background. Naval Construction Branch is in Adelaide, is the head office. We do the oversighting, governance and oversighting of all the naval ships being built or planned in Australia. So recently, Australian government introduced a policy through a white paper. So that's what government do. When every 4 years, 5 years, government release a white paper. What white paper is what government is going to do. Hello, can you hear me?
There's a lot of background noise in your voice. Your voice is not. Okay.
Is everyone muted? No.
Sorry.
Okay. Can you hear now? Is it better?
No, it's a lot of voice, background noise.
Let me switch to something. Just give me a second. Is it better now? Can you hear?
A little bit.
Is it still noise?
It's okay, sir.
Is
There's
it
some
better?
noise, but it's okay. There's some noise, but it's okay.
Just 1 second. Let me do something else. I'm just making sure I got Wi-Fi signal properly. I hope this is better now.
Yes, sir.
Can you hear me okay? Is that okay?
Yes, sir. It's fine, sir. So still there is some kind of background voice coming, sir. But it's fine. Your voice is better now and clear.
Better now. Okay. That's good. Okay, so I'll continue. So this is Australia's shipbuilding is looked after by our construction branch, head office in Adelaide. And we are a part of capability acquisition and sustainment organization. That is, this organization belongs to Australian government. The capability CASTI, it's called CASTI. CASTI is, the purpose of CASTI is to acquire and manage and dispose maritime or defense assets, including land and air and everything. So the naval construction branch is an arm to build all the ships in Australia. We have a naval shipyard in Adelaide and one naval shipyard in Perth. So it's a bit unique setup here. What we do, all the shipyard is owned by government. And those who are the contractor who gets the shipbuilding or ship design and shipbuilding contract need to come and build ships in this shipyard. Use the facilities, build the ship there. At the moment, currently, we have 2 shipbuilding projects going on. It's a hunter program, and the other one is OPV program, offshore patrol vessel. These are done by 2 different contractors. The hunter program is done by BAE Systems, and the OPV program is run by Lawson, Australia. So naval construction branch, I'm with working for the naval construction branch, and as a quality manager, and that naval construction branch oversees all these ship constructions. And we are an organization. We're not purely. It's a mixed organization. We got some defense people, uniform staff, and some civilians. It's about 50-50 ratio. Okay, some of the recent programs and the current programs we are doing is the recent one we finished, completed is Air Warfare Destroyer program. As we finished about 3 Air Warfare Destroyers, which costed about 9 billion programs. And the third last ship completed in 2019. The designer was Levantia, and it's built by Australian Submarine Corporation. Okay, the program in progress, we recently started the 100-class Future Frigate program. That's something similar to it. So it's much more bigger. Previously we did 3, now we are doing 9 frigates. It's a 35 billion program. And the first of 9 is estimated in 2031. builder design and build is done by BAE Systems. The other project we are running is an RFA, so PV for vessels. And there are now 12 ships being built. Out of that, two are being built in Adelaide, and the rest of them will be built in Perth. So one of the first ship is due for launching 16th of December. We're very busy working with that. So, defense seaworthiness management system. What is that? It is an outcome-focused, a regulatory body which want to ensure ships are safe at sea at any time. How do they do it? Basically it's a risk-based management system. Every activity is happening on the ship system there is a risk profile will be created, and if the condition of the system or equipment on board are not performing correctly, the risk will be reported to the Chief of Navy. So basically, it's a risk profile of the ship. If at any point of time, what is the problems, what is the risks, what are the biggest risks, or what are the risk profile of the ship, the Chief of Navy will be able to understand that. The ship has a missile launching system failure, or main gun is failed, or main engines are not working correctly, or due for docking. So all these information timely in a live tool it is reporting to Navy. That's what it is. So in order to do that, it is not starting not in a particular day. It's starting even the concept stage. So when the moment the government decides we're going to build these ships, these seaworthiness management system starts kicking. So I'll use the acronym DSIMS. That's what I written here, DSIMS. Normally that's what people call. DSIMS starts, as I've shown here, ship design stage, build, operate, and maintain, and dispose. And today, I will cover ship design and build stage. It is very, very vast topic to cover, otherwise I won't be able to cover every aspect. So at the end, most of you are students in university, and for you, it's better to understand. I don't think this system is very costly system to implement in commercial world. It is only Navy's defense, only defense system can afford it, because if the cost of the ship, building a ship is a 1 billion, cost of maintaining the system is another 1 billion. So normally commercial people won't go in that pathway. It's very resource oriented, but it's accurate. That's a good thing. So, as a summary, what it is look here is a few boxes. You can see that operating and supporting and design, build, acquisition, operate as intended. So this all this picture has significance. It's all aligned. So that's what seaworthiness management systems say. These all boxes are aligned. I'll explain what is all those boxes in the coming slides. So, next slide. How do we implement these things in shipbuilding? So, there are a number of requirements in these things. How in shipbuilding we implement that? So, how it is being done is that ensure ship design and products comply applicable requirements. Applicable requirements are I will explain how that we develop. It is including class rules, IMO rules, military rules and the standards applicable. The other requirement is to implement these things is correct data is used in design and build. So what that means is correct standards are used. If it is a classroom, the correct class rules are used. If it is a standard or military standard, correct standards are used. And that's what it says. And data means, when we design data, the designers use a lot of information. And also need to be ensured that they are correct. Another one of the important aspects is design can be verified, validated, and tested. That's one of the important requirements the DCs really need. If you design something, you should be able to test it. Somehow you need to test it. If you can't test it, you're not going to use it. The design is not valid. Unless, if you can't test the design is not going to be valid. That's what it is. For example, if you design and have it, you should be able to verify the structural strength. You should be able to verify that the fabric can take the structure, the safe working load. All the components can be tested. You got certificates of each component. The material used in the fabric can be verified. All this information comes with that in the design. So basically, the design and its components can be verified, validated, tested. Another requirement is ensure every activity, including design and test, are carried out by suitably qualified and experienced persons. So that's one of the key requirements in DCs. If you look at that little Venn diagram I have here shown in the right-hand side, so it's there. The blue says knowledge, the green says skill, and the red says experience, and in the common area it comes as competence. That's what it is. So in DCMs there is a process called engineering delegation process. So people, engineers and technicians who works for this organization and the DCMs should go through an evaluation process, engineering competency. They need to demonstrate, and they will get a delegation. So if you don't have the delegation, you can't act as a representative of that activity. That's one of the key requirements. The other one of the requirement is correct and agreed processes used to design and build. So if it is agreed process are, that's in the specification. When you write the specification, I'll come to that in detail in the coming slides. What is the agreed process is if the structural verification is done by FE analysis, then that is, if that's the requirement, that's what you need to do. You can't go and do different things. The agreed process has to be followed, and the agreed process in build is, for one of the example, is building process, or what else says maybe how you manage or how you do NDT, non-destructive testing. All this process. So agreed process has to be followed. Ensure the next requirement is ensure ship system is specific to its specification. So if there is any design, will have specifications. Design specification should be able to demonstrate. The people who design that should be able to demonstrate that it is done to that specification. And at the end, another key requirement is ensure residual risks are appropriately articulated, endorsed, acknowledged, and managed. So what it is if a product is designed, the designer should come up with a risk profile of that product. If it's a target, the designer should be able to tell what are the risks, what are the failure points, what could go wrong in that design, and what he has done or she has done to mitigate those risks. Okay, all right. So I'll just quickly go through this diagram. This diagram is a little bit customized diagram to show that how the DSIMs work. DSIMs start with something called operating and supporting impact. So it's as been marked here. It's an navy on that, this part. And on top, you can see that who is responsible for those activities. And at the bottom, I have mentioned how long approximately it will take to develop all these things. So operating and supporting that. Go back to that. So one of the key requirement of this is to capability managers develop an operating support interface. What it is that is what is the ship and what the ship is going to do. If ship is going to do air warfare or air warfare deployment, that means when the missiles coming through the air or aircraft carrier aircrafts through the sky is going to detect, or missiles is going to detect missiles, or is it going to do submarine hunting, or it's going to do land defense. So the capability managers need to define what are the capabilities he's going to install. He want to install on the ship, and what are the other supporting system he want on board. For example, along with that, he need a rigid boats or aerial surveying equipment, unmanned crafts, or torpedo handling system, or torpedo launching system, main guns, or vertical launch missile system, or ballistic missiles. So all these things, the capability managers put into this operating and support intent. As the name indicated, this is the intent of operation. That's the basic document. It could be a number of documents, and so we put together in a nice fashion for. This is a Navy document, and with this document, Navy approaches CAST. CAST, can you go and engage someone to build this? So when policy is given to CAST, or CAST start doing some engineering work on that. That's called the functional performance specification. So what it is as per the OSI, operating and supporting decides what are the capabilities to be needed or to be installed on board. Based on that, ST develops functional performance specification. Yes, again, as the name indicates, it's about the functional performance of the ships. What speed ship need to travel to achieve this OSI. So it could be, I have put some examples, example of one of the from functional performance, the ship shall achieve a speed of 28 knots at sea state 6 with a 7,000 ton displacement and 100% stores on board. These kind of statements are there in the functional performance specification. This is it is a big document. It explains. They determine what are the capabilities and systems needed on board to achieve this. So, for example, if it's a vertical launch missile system to be installed on board, you need to have a high rate of firefighting capability over big higher pumps. It needed high power to supply to the missile launching systems and cooling waters and missile handling systems. So all these they have to write in a functional performance stage. Functional performance is they need to exactly say that what they need to achieve. If the power line, the functional performance of the power line means it could be 5 bar, and you need to have 15 hydrants through the ships, and each hydrants need to deliver 15 meter roll, something like that. That's called functional performance specification. Once the functional performance specification is written, they do a risk assessment on that. What is the risks of doing this? Is the risk profile and functional performance specification. When it is ready, they start going out to the industry and go and invite bids. So the contract is built with a functional performance specification. They get a lot of options. They select 1 or 2 options or 3 options. So they start working very closely with those options. I have mentioned a couple of examples for functional performance specification. Is about a crane hoisting capacity of 800 kilo, 8 meter radius. The hoisting speed shall be 0 to 20 meter per minute. So all this one, if you notice that, it's all numbers they mentioned, it can be verified. So there's a quantity. The quantity is mentioned there. So it's a measurable specifications. Everything can be measured. That's the particular clarity of functional performance specification. So once a functional performance specification is done, they go to the industry, as I said, go to industry, look for various options available. Mainly, in order to reduce the risk, normally they go for a reference design, something similar, if done anywhere else in the world. So they go and be done. So that is a risk reduction. So that they don't have to do everything from scratch. So they approach, shortlist a couple of contractors, and they work with them. Once the contractors are shortlisted, it's not the proper contract is not signed, the initial contract. So they go and do an initial contract signature. So in that case, normally Navy will pay for that expenses of taking part in the bid. In OPV's case, there were 3 contractors bid. Finally, Nurse in Australia got the job. So once the 3 contractors are 3 or 2 contractors are selected, what they do is they start developing ship specification. So the ship specification is developed as a company exercise. It's done with the contractor, the potential contractor, and castee. What do? They convert all the functional performance specification into ship specification. But in order to do that, what they need to do is they need to add a lot of requirements. So I'll put a diagram here. This is the functional performance specification. In order towards the functional performance specification, they add, see here, shock and vibration, noise, and magnetic vibration, magnetic and vibration requirements, inter-system requirements. What inter-system requirement means, there are multiple systems on board, like a power system, control systems, fire line system, bilge system, water blast system. These all need to be integrated into ship's IPMS integrated platform management system. So this is what it is called, integration. So that features all will be developed intra-system requirements, optimization requirements, and durability of the systems. For example, durability means how long each system needs to function without any defect. So every time when the system is designed, it has a particular life. Within that life period, that system gets replaced. Most state is about 30 years, is on for platform systems. If it is a combat systems, normally 10 years. Maintainability requirements, so that's one of the other key aspects. Whatever systems they develop should be able to maintain. Safety, personal safety, environmental requirements, so pollution control, that kind of things, quality requirements, and ship design requirements. That's come with the class rules, IMO, and that kind of things. So all this will be added to a functional performance specification, and you get a ship system specification. Some cases they do ship system specification and combat system specification are done differently because of the confidentiality or the classification of the document. Normally, combat system is done by separate team, and only people required to get access only will be given that relevant data. So it's some cases it's done separately. If the ship is very small ship, normally is one specification. So one of the important things again when they write the specification, the requirements shall be verifiable by test. So sometimes all the requirements cannot be verified by test. That if not, that shall be verifiable by inspection. Okay, on to the next one. I'll jump this slide. I'll come back to this slide. I think it's a little disorder on put wrong order. So I'll come back to this slide later. Okay. Now, so as I mentioned, every system needs to be tested. So the test activation evaluation program we called. So test and evaluation program starts from the day one onwards when they engage the contract. So the ship's life cycle, the program runs through the life of the ship, through the ship is disposed. They divided that test into mainly 6 categories here. So it's all very written what it is. The category 0 means demonstration through modeling and simulation. So when the designer is engaged, they need to do some modeling analysis, which is it could be one thing is stability, seakeeping, the structural, finite element mathematics or analysis. Category 1 is environmental compliance. So what that means is again the MARPOL requirements is one of the requirement which comes in the picture. The pollution related environmental. What are the impact it has to the environment? That pollution related is one thing. The other thing is the material used. Material used in the shipbuilding. You can't use zinc or lead contained materials. Contamination or asbestos, or the material that can be a harmful environment, or the building process generate toxic fuels, which is not allowed, or what else? it's kind of things, environment compliance, which is some systems, if in order to install requires a lot of damage to the environment, they just give up. They don't do with their systems. The next logical progression is factory acceptance. Before we didn't reach to the design, but the factory acceptance requirements will be defined very, very early in advance. For example, main engines, propellers, how they accept these materials into the service. They define that. The reason for that, main engines or propulsion system requires 2 to 3 years of advance order placement. Otherwise, you won't be able to purchase it. So they do this kind of critical equipment as early as possible. Next category is ship integration acceptance. So what it is once the ship is built, I'll come back to that, the build stage a little more in detail in next slides coming, but I'm just going bit ahead. This is an assumption that ship is now already built. Now what we do. In category 3 test is system integration. Various systems are integrated together, cooling system or fuel systems, integrating with other systems. Harbor category 4 is harbor acceptance. You know what it is in all the basin trials alongside. And category 5 goes to sea. And category 6 is operational test. Operational test is purely done by Navy. It's the gun, operation of a gun. It's a ship that won't do. Navy has to do. Operation of missile launching or propeller handling needs to be done by Navy. So that's what it is, category 6. So category 5, the shipbuilder's job will be finished. It goes to category 6, Navy take over, and category 7, in service and post maintenance activities. And I'll come back to these build stage test later. Just briefly to sorry. Okay. So now I said the next step from functional performance specification is ship system is developed. Now it is once ship system is developed, they will ask the contractors to put the price tag on it. So that's the time they select the contract. So the reason it is being done is so before they select a contractor, they want to know this contractor can deliver a seaworthiness assured material. If they can't demonstrate their design by us, they are going to proceed. So what the designer has to do in order to develop the design? So shipyard, the next step is once the ship specification is developed, the next step is the shipyard go and do complete. They take the ownership of ship's system specifications. So the FPS2 ship system specification, it is a combined cashier and contractor exercise in the beginning, but once it is the contract is awarded, they hand over that to the contractor. Now you take over this and you start designing the things. When you progress through the design, you demonstrate the combines of this specification to us. That's what SC asked for. So in order to demonstrate that, they start designing the ship. They write ship system, each system detailed specifications. I think I made a mistake, that typo there. Detailed design, detailed ship system specification. But what it is they go and they write all the features of the specification, all the technical details of the specification, what material it is used, is it copper nickel or steel or plastic or fiber, and whatever it is, they write all those details and they start designing, developing the detailed design report. Detailed design report is purely all the calculations they used in the design. They come up with a system description, what it is, what the system do, what system really, how they are performing, how that system needs to be operated. So there comes. So all these steps will have a risk assessment, and Cash will be looking at that. Okay, when the system is developed, do we have enough people? Can we do this? Do we have skilled people in our Navy to operate this? Or if this kind of systems we adopt, do we have to retrain our people somewhere else? So what is the risk? So every step from that time onwards is risk assessed. And a risk profile will be created, and it will be online as a live tool. And all the Navy higher officials able to see this, what is the risk. Then designers develop functional level drawings. These functional level drawings are mainly demonstrate what the functions are going to create. It's not production drawings. Very minimum details are there in the functional level drawings. The next step is the production drawings. Production drawings is all the details. What is if it is a structure, what is the thickness, what material is, what are the spacing, how the blocks, how the ships are being built. All the details will be there in the production level drawings. Installation drawings, how a particular equipment to be installed on board, how it is to be handled, how it is to be lifted, for example, shaft. All these will be determined there. Then comes equipment manual, test procedures. Okay, there's one of the other hiccups there. So when the design is developed, they also need to, along with that, all the test procedure need to be developed. So if you develop a design, there should be a test procedure. Okay, the other thing that goes along with that is the safety cases. Safety cases means is the safety of the design. So they need to put a safety case. The kind of failure arguments they need to contest with cash sheet. So they put that in the document, trying to demonstrate that the risk is very low. That's what it is in the safety case. And ILS information. ILS means integrated logistics and support. What it is, what are the spare parts are used, where the materials are coming from. If it is Australia, we don't prefer material coming from China. So this kind of information has to be there in the design package. Now, once the design package is endorsed and it's good to go for production, that period is almost 2 years, as I've shown in the first slide here. So here is the operating support intent, functional performance specification, ship specification, combat system specification, then ship design is done, safety case is done, test protocols are developed. Now, this is, you can see that a little longer, the green count things, the risk assessment here. So risk assessment, I told you, it starts from the day one onwards. It is an ongoing thing. It's keep on going till end of life of the ship. Test and evaluation program, it keep on going. It start from the day one onwards, going till the end of the ship. Compliance assessment process. So what that is so all these operating support intent, functional performance specification, ship specification, all these are requirements. So when the design is progress, you need to demonstrate compliance. So what they do is a verification cross-reference metrics. They put all the requirements in one place and give evidence against each requirement that, okay, this is compliant, this is compliant, this is meeting, this is meeting. So that's what the compliance assessment process. So Cashley will verify this compliance assessment and will give a tick in the box, then only the designer can proceed. And another big aspect is the ship security program. So when the designer doing, so they need to make sure whatever data they created for the defense or this cache is the data is secured. So that means during that initial period or any time, they should not be able to, no one should be able to hack and find out these details. In order to avoid that, what they do is, when the contract is awarded, Cashley will ask, okay, now contract is awarded, you come with your system, your computer systems, plug into our systems, and you work in our system. You're not working in your system. So that's what they do. They come and work in different systems. It's a plugin. Typically, a company called the BAE, they just bring their complete surveys and everything, and the server can be hooked into the different system. And whatever going out from that server, defense will be monitoring what is going out. We will make sure not data related to their ship is disseminated to anyone. Okay, so I now covered up to ship design. Now we going to start build. So that's the shipyard is building. So before they start building, assurance, they run assurance program. Build assurance program. What it is it starts again at the moment the design is detailed design. There are a number of processes in design acceptance, detailed design review, critical design reviews. I'm not going into that details. Once the design is declared good to proceed with shipbuilding, actually comes again that their construction branch step in, they come and assess the shipyard's readiness for building ships. So, as I said, the contractors need to come to this shipyard and use that facility. So they need to appoint their staff and they need to prepare everything. So normally the shipbuilding starts with the steel hull, and there's some major machineries will be ordered, like a missile launching system, main engines, propellers, radar, anchors, these kind of critical long lead items will be ordered. And they start the keel laying of the ship. And the keel laid, it is in a block by block. It start fabricating blocks. So your construction branch will run an assurance program. Assurance program is every step. There will be instructions first. For example, in a hull fabrication, normal tests are the steel material testing. Yes, materials will be randomly tested for its chemical, mechanical properties. There will be some fatigue testing, and structural. When it comes to structural, the welders will be tested. Normally, it will be done at a classification society. If it is not classification society, it will be done to Australian standards or some military standards. So procedures are established, quality systems established. Your construction branch will do the surveys on the structure to make sure the ships are being built according to the design. I'll just go and show you some of the little procedure progression here. Sorry, I'm just jumping across. So here is the build assurance process. You can see that. The PRR means production readiness review. This is an assessment by your construction branch. The shipyard is ready for producing the ship. the material receipt inspections, block fabrication, block outfitting. Block outfittings means normal the pipe fittings or pipe clamps, cable trays, cable electrical cable penetrations, pipe penetrations, foundations of machineries. These kind of things are being installed at that stage. After that it goes to a blasting and painting yard, and once that blasting painting done, it is consolidated, and electrical cabling will be installed, piping will be installed, then outfitting will be done, where there all the equipment comes there. They come and install all the equipment of piping, outfitting. So at this stage, all the blocks will be assembled together and welded, and all these piping system, cabling system, accommodation, insulation, paneling, all these will be done. So when these process happening, there are a number of parallel process going on. One is non-conformance management system. Non-conformance management, what it is, see, as I told you earlier, the compliance assessment. So there are some requirements is probably met. One is if the shipbuilder cannot do as per the design, deviate from the design or deviate from tolerance. So then they raise something called non-conformance, and this non-conformance need to be fixed. It's required, need to be fixed. So that happens from day one always to ship's delivery. Another function is configuration management. It is the version control of documents. I told you before, the design package comes with design drawings, detailed design reports, test protocols, files, integrated logistics support systems. Any of these documents has some variation, something needs to be changed. So that comes configuration management. The configuration is controlled. So there is a process that you keep on updating these drawings. The other things we do as a construction branch is the process audits and periodic process reviews. The process used in shipbuilding are one of the example is melting process. So we regularly audit that process. Are they doing the right thing? Are they using qualified welders? They're correctly testing the welding. All this will be audited, and if there is some problems, that process will be periodically reviewed. Period means if any improvements needed, that will be brought in place. Another thing is the conformance of build requirements. So there are sometimes some requirements in the specification you can't implement it to design. It is, for example, a pipe needs to be so much away from a bucket. It can be mentioned in the design, but it's really need to be implemented, means you need to verify on the bucket. So these kind of things are handled by conformance of build requirements. So once the systems are installed, it goes to install first and inspection. So basically, the team comes and verify whether the systems are installed correctly, all equipment on board is good for activation. That once that is done, it is going through another desktop review process called system readiness review. There's another slide, I will cover that. Then system readiness is reviewed. They start activating the system, and the ship will go harbor acceptance trial. What other systems you can demonstrate, you can functional test in harbor, they will do that. Then ship goes to sea trial. So part of harbor acceptance trial, inclining stability exercise also counts. So inclining test will be carried out in harbor. Then ship proceed to sea trial. Once successfully completed sea trial, it goes with a delivery certificate. So this is the build assurance process. Now I'll go back to some of the areas I missed. So as I said, we do inspection and surveillance. So what are the key areas we inspect? Deviation from any functional performance specification. So instead of the functional performance specification says, or the file line need to demonstrate 5 bar, instead of that, some states showing only 4.5 bar. That's one of the is a deviation. Just as an example. Other surveillance areas, production test feasibility. What it is can we do safely test this? Is there any problem when you lift a crane, when they lift a 5-ton load? Can they test it safely? Build conformance as per the design. I already spoke that. Verifying non-pursuit requirements, quality best practice requirements, non-conformance process oversight. We jump into ISO smart probe requirements, and is there any risk? So that's another thing. When inspection is going on board, even though we can see everything in 3D model or design drawings, once everything in place, still there will be a habitability will be need to be tested. So sometimes in drawings it shows 500 mil clearance, and initial and the effective clearance will, even though it's 500 in a particular shared location, it was in the drawing 500, the other locations is not 500. So that the person cannot pass through. So that's a risk. So we log that as a risk, and we do changes. That's called engineering changes. I told you, I said I'll come back to this. So in order to make the life easier, in shipyard, the stage testing is much more divided into much more finite stages. So this is what we use during shipbuilding, because it is much more easier to follow. There is 7 stages during shipbuilding. First are divided into seven stages. Stage 1 is material receipt inspection. Stage 2 and 3 is when you build ships, including hull, piping, electrical, insulation. So all comes in that stages. Then stage 4 to 7 is harbor to seaplanes. Special test is where they need Navy to come on board, like operation of mega or some special torpedo handling system. All these things you need to consider as special tests. You need Navy people to come on board. Okay. So when we do these tests, we called something develop. What we call this test sequence network. What that means is that every test needs to be contained safely. So there are certain tests you can't do unless you do a few other tests as a predecessor. For example, the crane load testing you can't do until you demonstrate the crane is actually sound. All those components has got certificates. So crane's foundation structural testing will be a predecessor to crane's load testing. If crane load testing is not done, you can't carry out its functional test of other swinging or the various other lifting operations. You can't carry out. So they come up with something called technical sequence networking. It is a schedule, that network will say when to carry out the test. And another example is the pressure vessels. you don't, if you don't have pressure vessel tested and certified, you can do and activate the pressure vessels. So this sequence network is a safety program which making sure the workers are safe and no test is carried out with its predecessor test. So I told you, test and activation evaluation program, maybe the requirement cannot be tested. So there are some requirements cannot be tested. So in those requirements will carry out instructions. So for example, welding parameters, for if it is a robotic welding machine or welder manual welding design, there are some parameters need to be followed in welding, voltage, ampere, that kind of things. So these kind of things are will be monitored. And for example, painting, coating, there's no requirements in classification society or anything. So these kind of things will be done by inspection. Height of an element, still height of a door, or a compartment, a particular compartment is completed or not. That will be done by inspection. So all these, as I said before, all these are tracked and traced through VCRR. It's called verification. Verification is the process is are we building the ship correctly? So you do it's a 3-year process shipbuilding. So you start with doing a wrong process in the beginning of the program and end up with a wrong ship, or ship doesn't make with a ship, you end up with something you can't use. So that's what is verification. Are we using right process? Are we on the right track? That's what verification means. And validation is whatever the job done, are we getting the right product, right result? Is that what we want? So each program will be run, verification and validation process will be run from the beginning to end of the shipbuilding activity. So I've drawn some diagrams: stage 1, stage 2, stage 3 testing, and other process along with that. Go into details of that. So another important thing is objective quality evidence. What is objective quality evidence? So I've shown some certificates. So that's what it is. Some certificates, inspection reports, NDT results, or a test report, successful test report. All these called objective quality evidence. So quality is achieved. That's what it says. So that's an evidence, and we need to combine these evidence together to demonstrate that we have done everything possible to make that ship safe. So I told you before, once all the ship systems are built and they are ready for activation, we go on to system readiness review. I'll be using the systems. Maybe I'll touch on what is a system. Go into that quickly. So before I go into system readiness review, I'll just explain what it is. A system. System is traditionally normal engineering is design methods are based on top to bottom approach. What it means is all the components are, all the system has got a number of components. The piping system has got a pump, you got electrical supplies, switchboards, you have valves, you got a control and monitoring devices. So all the components are there. The normal approach is that the components are assembled into subsystem. So if there is a piping system, go to pressure gauges, all the pressure measuring devices, all these are a subsystem. And the system is subsystem then into the big large piping system. And this is tested for decide its properties. And if that system, normal convention engineering, if the system doesn't meet, they'll just iterate, the pump not developing pressure, so they try to make the suction a little more bigger, or trying to do something else, or change the pump. In system engineering practice is slightly different. They go into, they develop the system and go into component level, and they come from the bottom level to, in system engineering, top to bottom approach is done. So it's beginning with the system as whole. It's a big picture, then understand what that system is to deliver. For example, if it's a fire line, what fire line need to deliver 5 bar pressure throughout, always need to be maintained, enough quantity of water, enough throughout nozzles. All these things, once it's understood, what is the subsystem of that going to do? For example, one of the subsystems is the electrical system, electrical power supply, control and monitoring system. Are they going to show a right reading on in the PMS? Or are they going to give power to the? Are they going to deliver the right voltage and ampere to the electrical motor? These kind of things are checked. So it is an opposite way of doing that. We understand that whole system and going into component. The other system is component. You got a sub-assembly component, and each component you understand and you go up. So this is the difference. It is an American way of doing these things. So Australian Navy follow the same thing, system engineering approach for safety management of complex systems. So I'll go back to the system readiness review. System readiness review is, once the system is built in place, we do a system readiness review. What it is, have you done all that was supposed to do? In the pipe, if it is a pipe, the pipe has been tested in the shop. If it is an electrical system, or the cables has terminated correctly, the insulation reading has been taken, or switchboard installed properly, all these documents, as I told you earlier, OQE, objective quality evidence, will be verified in a desktop process. If the team will be carrying out this job, it's a months of activities. They start, once the system readiness review date is fixed, they start very advanced, all this OQE verification, and it's and end on the right day with the right result. So basically, why they do this is to make sure the people are safe. So they're not going to energize a compressed air line with, say, 150 bar, and if that pipe is not tested to 150 or 100, the pipe is not short tested, then they can't proceed with system activation. So that's what the system readiness review is going to take. Once system readiness review is done, and the system readiness review board will give a clearance, say, okay, you can go and activate all the systems. So they start switching on all the systems on board. and it's once the system is activated, we can do all the tests, hardware tests, whatever possible tests you can do in hardware, they'll play out in the hardware. Then once the hardware test is done, they go to C and complete all the C plans. Okay, so I covered that, covered design package. Now I just quickly, I don't go into too deep into this, I quickly go through risk assessment, how do we do risk assessment. Okay, risk assessment is assessing the failure of system, where the things can go wrong. So it is done against for these. The risk has got mainly it is done this way. Risk has got a consequence. So what it means, if something going wrong, say if a crane fails, what happens? If a crane on board, it fails, what happens? Is it going to kill someone? Or it's going to create dump all the hydraulic oil into sea? Or what else it can go wrong? So they have assessed that against the consequences of that. What the problem is going to bring. That consequences are assessed against these categories. Mission is really they're talking about war. So for example, it's a missile, the main gun is going to fail. Is there any point in going to war? The vertical launch or missile launching system is not working. Is there any point in going to war? No. So that's what they do. So mission capability. Capability is the ability to do something. It is something outside the mission. Mission is about talking about war, but capability is something. The ship has got so many other functionalities as well built. You know, to detect enemy fights or enemy ships, big spy radars, or rescue someone from the sea. All these things are there. So if the capabilities are compromised or any issue with the technical seaworthiness, the ship is stable, the ship can move, ship has got it has the propulsion system working properly, all these things. Support. Is there any problem? If there is a problem, is anyone can support the system? Anyone can support the ship from shore. So that risk will be assessed. Safety. With the ship staff, are they safe? Can this failure create any problem to ship's safety? Environment. Is this ship going to create any problem for environment? So these factors will be assessed as a consequences. Then we get a likelihood. Likelihood is there. So as you can see that descriptors are there. And almost certain, probable, occasional, improbable, right? So this is, again, this is assessed by an experienced engineers. So they prepare metrics in this format. They understand the context, assess the hazard, then controls are implemented. Controls means, how you mitigate those risks. How you reduce, how you manage it. That's what it comes with controls. Then once the controls are implemented, you assure that it will be working properly, not just words. It's really, you need to do something there, review and log whether it is okay and it's good. That's what it is. So risk assessment, consequences rating, the category, there are a number of ratings there, how you assess consequences. Again, it comes with the metrics. So this has got a nice score there. So here is these, what is it called? I don't know what this color is. These very green, these greens, light greens are very low risk items. When they calculate hazard risk index, if they come in these boxes, So probably these people can sign that and endorse. So SQAP means suitably qualified and experienced people. These people can sign off that. When it is a little more risk category, that the green is much more higher category. If that risk is only commanding officer or a commander can sign, then when it is in a law, that is another level of people, high level people can only sign that risk and accept. So for example, the Chief of Navy, so for example, the Chief of Navy wants to send the ship to sea for fighting another ship. So when he coordinates the ship to go to sea, there is a risk that main gun not working. So the moment that activity happens, the risk will be appeared in his system. Say, look, you are sending the ship to sea, but you don't have main gun available. So Chief of Navy decides, this operation you don't require main gun, go to sea. So he is the person he can endorse. So if main gun is not there, the risk is catastrophic. You can kill that ship, you can sink that ship. But Chief of Navy can make that decision where to go. So that's what these red boxes say. So these red boxes means only Chief of Navy can sign. Okay, so that's what the risk management system shows. I think I covered almost everything. Let me have a quick look if I didn't cover anything. Yeah, I think I covered everything. So if you have any questions, I can answer. Otherwise, I'm happy to take. You can send me an email as well if you don't have anything at the moment. All right.
Thank you, sir.
All right.
So now this comes to the end of the session. So needless to say, this was a very informative, very wonderful session. So if you have any queries, feel free to ask. So, sir, we have one question in the chat box. May I read it?
Yeah.
So the question is, what are the risks that are to be considered on regulating and managing the Australian defence vessels under the DSWMS?
Okay, so risk. Okay, I already covered that, but I can go back to that. So that's what the risk related to mission. Mission means if the ship goes to a war, what are the risks? What stops the ship to fight a war with another ship or an enemy? And that's one of the risks you need to your systems on board is capable to do that. That's one assessment. The other is the capabilities. The ship is fitted with several capabilities: rescuing capability, spying capability, spying the planes, spying aircrafts, or submarine, or spying another country. So all those things are built into capability. The ship has everything in place to do those actions. Or another is technical seaworthiness. The ship is stable. She can travel at the speed it designed for. There is another risk. The support. Any support that vessel from shore. And that means, if the ship need a complete breakdown on some of the things, can you deploy your helicopter or aircrafts and deliver that spare parts on board if they don't have anything? These kind of supports, and the environment. If the ship is going to make harm to the environment, the ship has got any damage that leaks fuel into sea or discharge something else into sea, these kind of risks. So that this is what we assess mainly the risk against. Does that answer your question?
Yes, sir, it's clear.
Yes, sir. So we have another question from Vishnu PS, and it
Yeah.
goes like, what is the best corrective measures in restoring the vessel's seaworthiness?
Corrective measures is the repairs, carry out maintenance, planned maintenance. There are when the ship is get into service, there will be a maintenance requirements will be set. So you carry out the right maintenance, and if there is a breakdown, do do breakdown repairs by competent people. That is that's a major activities it's being done. Is anything in chat? Is someone asking questions? Okay, so yeah.
Sir, this is all very, and thank you, sir. And before concluding the session, we have one token of gratitude to Mr. Sanu Rajanbabu for being with us and delivering his wonderful speech, wonderful presentation with us. So the token will be
Yes,
presented.
I got one more question from Akash. Do you want me to answer that? Maybe I'll keep you
Oh, yes,
touched
sir.
on
Yes,
this
sir.
one. How do
Yes,
you
sir. Sure,
maintain
sure.
water tightness and seaworthiness of a ship? Okay, good. Okay, water tightness is Akash. Water tightness is one of the important thing, one important aspect. There is a little dashboard itself will be developed during the building to ensure the water tightness. Main water tightness issues are the hull valves or the watertight doors on the hull or the propeller shaft penetrations or rudder penetrations. These areas are either it will be tested for water tightness. The valves will be anyway. It will be tested. Valves will be used, and when once it's installed, it will be tested before the ship will be put in water. Sea chest where the ship's water is one of the other areas. So the sea chest will be tested to a pressure. Other thing is water ballast tanks. So these will be definitely hydro tested, water tested to ensure the water tightness. And if the hull welded seal is generally will be vacuum box tested. The weld will be once the weld is done, it will be done in vacuum box from the other side, and we make sure there's no pinholes or no leaks from the other side. So that's a big exercise, and at the end there will be a watertight integrity dashboard will be presented that to demonstrate that we have tested every opening. And one of the other aspect is the cable penetrations on bulkhead. That's one of the important thing we test generally. Okay, I think that's what it is. Is there any more questions? I think Akash.
No more questions, sir. Sir, again, thanks for attending the session and thanks for your answers. And now we have a certificate of gratitude. It will be presented on the screen, sir.
Okay, thank you.
Sir, I think you can see that.
Oh, I can see that. Okay, thank you for that, and yeah, I thank you everyone for attending this session. I think this is my opinion is this present this seaworthiness different seaworthiness system. You can't implement this in commercial work. Definitely, it's a very costly system, very highly resourced. Only navies can afford. And, if you our department students, if you guys going into Canada or US or UK, you can see similar system, very close, very similar systems they use. It is very highly rigorous, resource oriented, but at the end, it delivers the result. Let's make sure people are safe, and so keep this in mind if you guys are going. Risk assessment is one of the important things you need to have an understanding on when you pass out from your university.
Yes, sir. Thanks. Now,
Thank you for
now,
this talk.
yes. Now I request everyone to have a look at the chat box and please fill up the feedback form provided there. Now, I hope you all enjoyed this webinar very well. On behalf of the stars, and I would like to express my sincere gratitude to Mr. Sanu Rajanbabu for taking time from his valuable schedule and making this very important informative webinar for us on this very special topic. And also my sincere gratitude to all members of those trusts from all over the world for this exceptional commitment to the department. And on this occasion, I would like to thank Professor Dr. A. Madhirajan sir, our HOD, for being a constant inspiration and support for us in all the activities conducted by the Students Society of Naval Architecture students. Last but not least, I would like to thank every faculty and students who put a sincere effort to attend the webinar and make it a grand success. And always feel free to contact us for feedback, and it's highly appreciated. Now our webinar has concluded. And that's all. Thank you again, and you may leave now.
Thank you.
Thank you, sir.